guys want to do this? Do we want like to make a bunch of issues, or do we want to just sort of like go at it in a Google Doc first?
Yeah, well, let's talk about that first.
Okay. I'll maybe get a Google Doc started so we can keep track of the things. How's it going, Thibaut?
Good.
Doing all right? Would you mind flicking it? Or is it on?
Yeah, it flipped for a second, but maybe plug your wire.
My computer thinks it's plugged in.
Oh yeah. Yeah. All the time.
There we go. Thanks, Tom.
Frozen in time.
Yes, exactly. Cool.
Hey, Mike.
Hey, Mike. All right, so I'm going to start a Google Doc in, let's do in development proposals. Cool. So, perfect. Still like almost right 2016 doing dates, which is kind of sad by now.
Yeah, that's half the year.
Yeah.
You're not gonna learn now.
Oh man, it's already halfway over. Anyways, let's not dwell on that.
Moving on, Lindsay.
Let's cry for a second.
I'll just take a moment to acknowledge 2017 is half over. Cool. Yeah, so Sarky and I were chatting yesterday, and he had mentioned a few things that are bugging him in the EM code, and thought we should document that. And also just like other things right now that are sort of sticking points or things that we can rally on and like that just improve sort of the day-to-day stuff, I think. Because I know like a lot of the issues we have right now, I think are sort of very forward-looking, which is awesome, and that like helps lay out a roadmap. But there also is stuff that is just like annoying right now and not hard to fix. Yeah, so Sagi, do you want to start us off because you had some stuff yesterday?
Yeah, well, so I was rewriting the NT code. Oh, well, like, not
Reviewing the NT code.
not well, like not rewriting. It's completely just separate code from Goodness.
Oh, okay.
But mostly, yeah, it's for a tutorial for MT 1D case. And I found like quite a few places where you are very inefficient.
Okay.
So for instance, like, can you? I could potentially.
Do you want me to share my?
Yeah. Well, yes. Or. Yeah. I'll join then.
Okay.
Is it
It's in general in Slack. I can add you by email if that's helpful.
No, I think I can join. Um, Can you? Yes. So for instance, the first thing, I think this is probably an interesting point. People may not know. It's a specific for EM code, and so if you look at the base class, and there is this lines. So this is what you store in the class, and whenever you update your model, and you want to remove it.
Mhm.
So I think you're expecting that's only happening when you're after your first iteration of inversion. But the one iteration includes the field computation and JVAC and JTVAC and multiple of them, because like you're doing CG, it depends upon how many CG iteration are you doing. So there could be potentially 5 of them, each JVAC and JTVAC.
Which you maintain J.
Yeah, for instance. And sometimes like that computing that maze matrix is cheap. But if you think about like how many matrix vector product we do, it's actually a lot.
Yeah.
So
throughout the chain of it.
Yeah, and then when I was writing the MT code based on mostly the structure of the EM code, and I was confused because it was updating a lot. Whenever I compute the JVAC, JTVAC, it was updating, and the reason why is that because that the time it's so whenever you do the self.model, that updates.
Whenever we set self.model,
Yeah.
or whenever we
Whenever we set
call
whenever we set the self.model,
Yeah.
it updates.
Right.
So, but this self.model is always in JVAC and JTVAC. I don't think I'm not sure, but we don't need the. I don't know. I ended up removing self.model in my JVAC and JTVAC for the MT code.
Yeah.
Which I think better.
Yeah.
Because only fields need that, or so you can take it, but you don't need to set the self.model. So I think what we need to do, we just need to comment this line
And pass on M. And
because M only required for your fields, and then that's only when you actually update your model.
Yeah. I guess my hesitation doing just commenting it out is that if you actually do just want to compute the sensitivity,
it's still fine because you need to pass on M to a field, right? In the field, that self.model is so we're doing twice.
I see.
So there's no point
Right.
doing that, and then that actually so you do unnecessary maze matrix computation.
Yep.
And the probably mass matrix was fine, but what I was trying to do was something along this line. Say,
Hey, Doug, 1 second. Can you just one question? So your fields here are resetted. They're fixed right now, right? As long as you don't do a self.model, F is computed only once for JVAC and GTVAC.
So what's actually happening in the inversion?
In CG, for instance, you're in CG, F is constant, right?
Yes, F doesn't change.
Exactly, and then you just reset at the end of it.
Right.
Sounds
Exactly.
good. Yeah.
So it's kind of good to remember. It's only when we call the fields, that's actually when your model is changed, and then we need to recompute the
Reset
fields.
everything.
But what's happening in the inversion code, we first compute the fields and pass it through this keyword.
I see.
So that's actually what's happening.
Okay.
But sometimes people want to just evaluate the JVAC in the outside.
Without knowing the fields.
Then so if you don't pass F, that'll smart enough to compute F in the code. So
Sounds like a big deal, man.
Yeah.
If you need to recompute every time.
Well, we're not recomputing the fields every time.
No,
But I
but
agree.
all the operators would be recomputed. Yeah.
So the only thing that we might want to do, just as like a safety, is basically call self.model and just check that it is actually in fact equal to m if you pass it.
Yeah.
Because if you were to pass, right now, if you were to pass f and like a different m, we wouldn't catch that. So like if you pass f and the m didn't match it, we wouldn't catch that.
Yeah.
And so that's sort of the only n number case that we should watch for.
Yeah.
But if you're passing f, then
Yeah, or like we may not even need to change that, but we need to change the base code,
yeah,
which actually like can ignite that delete stuff.
yeah.
So that like that checks whether if n is same, then you don't need to delete.
Yeah.
So that's one thing, and
So how much speed up does that give you?
oh, I don't know. I think I haven't tested for actual SimPEG code.
Okay.
Okay, so that's one thing. The other thing I have found. And the reason, so I think probably mesh matrix might be fine. But like for instance, if I want to do but if I want to do something like this, for instance, say, if you want to store your factorizations, say A matrices, like this. So there's a potential way that you could do. So you set it as a property and then store your A in when A transpose in. So if you have a large enough memory, that's a much better way because like sometimes factorization takes a while. Then, well, for instance, like you just need the one factorization for each iteration.
Yeah.
So that because the model doesn't change.
Exactly.
So you can actually store it. And
otherwise,
then,
you're losing the gain of doing a direct solve, right?
Yeah.
If you're recomputing your factors every time.
Yeah. So, well,
Yes
like
or no,
yes or no.
Yeah.
With isn't like the reason why we're doing a direct solve is the back step is much faster than doing all the iterations of the
True.
Part of it, but also like
accuracy.
if you can, accuracy.
Oh, because like we're still getting that because we have multiple right-hand side.
Yeah.
But we're not recomputing for multiple right-hand side.
Exactly.
But for like a say field when you're computing the field in JVAG and JTVAG, well, it could be they are same, so you could reuse it. But we're kind of recomputing. So if you consider that, like say, if you have 10 of those like a computation, you're 10 times of doing factorization, which could slow down your speed a lot. Of course.
So do you think like even basically when we set up the problem, if we just have a keyword that is like store factors, and then we do this or not?
Yeah, something like that. So that's I think we probably need to consider that as an option.
Okay.
In both frequency and time domain code.
Yeah.
And that'll speed up quite a bit, I guess. In the case when you got enough memory, that'll definitely speed up a lot. Yeah.
Did you solve your problem? Because when you're doing back solve, right, you were getting some like crazy slowdown because you were in a for loop or something. Is that did you solve that one? You remember you were?
I don't like it. That was I think that problem was kind of mingled, but I think it wasn't just that matrix vector product. I think it was something inside of the mesh matrices because like whenever we are looping over, it wasn't actually store a full mesh matrix, but like a part of it, and then like a concatenate and then compute.
Okay.
So that we were doing in that for loop.
We should have fixed now the concatenation.
Yeah. So that has been fixed.
Yeah, because that's, if I remember well too, that your problem was that like the matrix product was faster than the matrix vector product. Because one was implemented like with a very efficient library, while the other one was kind of like a,
Yeah, well, I wasn't 100% sure because what was Ari? What was his
Oh,
the
Jake.
Finland name?
Yeah, Ari.
Finland's.
Yeah. All right.
There's two guys, like the one and Jake.
Jake Vanderglass.
Yeah, he actually replied there could be fundamental issues in SciPy,
Yeah.
but the Ari showed that it was a problem of like how you slicing.
Yeah.
So if you kind of do a trick where you copy and then like do it, that actually helped. So
I
yeah,
think that might actually be like he hacked around the issue in sci-fi.
okay.
Because so what the matrix product like actually accesses the BLAST library. So that is like your very base level machine code. Whereas the matrix vector product was accessing something compiled. Which I think like on some machines probably would make a huge difference. But on others, like it absolutely makes a huge difference. And especially because we're calling matrix vector products.
Constantly.
Yeah, I haven't like actually fixed it.
Solved it. Okay,
Yeah,
okay.
because I think we may not want to change it, but we may want to change the actual SciPy code.
Yeah.
Then we don't need to change that in our code. So.
But how big of a fix would that be in the?
I think, because why I figured, I think that's actually make a big slowdown in the code, because that's a big difference. And then what we misunderstood was our matrix vector product is cheap, but that wasn't cheap. That was my feeling, and especially for the DC code or IP and DC code, because what I was doing, because I was exactly doing the same DC code, but I have a multiple time channel. Then your matrix vector product is 10 times more or 20 times more. And so I did a simple calculation. How long does it take this inversion? It was not a big size, but the 20 days or like 10 days to actually compute, like do the full inversion. Well, so what I ended up doing, I stored the sensitivity matrix rather than like doing this matrix vector product. So I just compute the full sensitivity matrix once.
Then it's a real matrix vector.
Yeah, then I think that's actually like, so then I could do really fast, like for a relatively small size problem. But like that actually happening in all the codes, all the EM code. So in DC code, all the nonlinear inversion code, which is I think that we need to fix that. I haven't checked. I haven't visited.
Do you guys want to see on like where that issue is?
I kind of remember. It's when you're hitting your sources when you write it side through.
I just put the Stack Overflow link.
I remember seeing you test, so I mean, it was pretty compelling.
I'm going to share my screen. Okay, so what it is it's in.
Oh,
that's you.
It's great, because now it's actually on people's radar. So if we open up this guy, if you have a look, basically, and compare. So this guy is CSR to matrix vector. Like it's looping and not using BLAST code. Whereas if we look at matrix,
yeah, there's a certain function, CSR method.
That's C. That's C language, no?
That's a C.
there is.
There's a chunk probably C, and the rest is Python.
I thought it called something else here. Oh, CSR map vex. Right.
Oh, sorry, not that. Yeah, thanks.
Vex.
Yeah, there's X pi. That's
Yeah. That's the Python part.
I think that's a blast. The other parts are mostly C. So when they're looping over, there was our C code, and then in the loop they use that blast package. I think that's potentially matrix vector product.
I think so, yeah. Yeah, so like we can.
And that was the slow part of it.
This one's fast.
This one's fast.
Yeah, if you do. This one is slow.
That's actually a for loop, simple for loop.
Oh,
We're
okay.
just going through and summing.
Okay.
So this is a fix, like what is probably a good trajectory here is to actually just go with basically translate some of these Stack Overflow to an issue in SciPy. And then like either we can try and fix this, it shouldn't be too hard. Like I'm not familiar with BLAST, I think we can pattern match and probably figure it out.
Yeah.
Or somebody might be willing to.
I think probably I should have done that. Yeah, making any, because I was a little bit confused because this Finland guy, he actually showed, is it he or she? He showed a certain way that like he could do it.
Yeah.
So I wasn't sure actually what's the real issue.
Yeah.
So I'm still like not exactly sure whether like that's a problem or not. So
Yeah.
that was a reason why I kind of stopped. But because like the only problem he showed like just a sliced array considered a certain thing,
Yeah.
and then he just need to copy that and then make a new array and then do a loop. That actually helped. So I wasn't sure.
Okay.
And then like he actually found that concatenation in the mass matrices.
Yeah.
So yeah, that was something that I wasn't.
We should try like.
Maybe it could be me.
Oh, hello.
Oh shit! Oh.
I'm gonna stop sharing my screen. So that's distracting. Yeah. So if we try your test again, because it should be comparing with the H stacking, like that should no longer be an issue.
Yeah, I'll test it again.
Yeah, because I thought we could get some homework.
So that's another thing, the final thing. So I'm not really happy with the all of this basic survey class, how it works. Like the source takes the receiver class, or I get that kind of what takes what. That's fine, but the for instance, say here, if you look at the eval, and what's actually happening, it's kind of hard to see, but I'll show you what I've done, for instance. So here's what I was playing. So say in the EM code, there's a real and imaginary part. And so this is the projection. So F is my fields. And I evaluate to a location where I got the receiver. And you don't need to do this matrix vector product twice. But how the current code works, because you have a receiver for a real part and then another receiver for imaginary part. And by doing that, you need to do that process twice. Mm-hmm. And also, that's not only the fields, but when you're doing the eval, like a JVAG and JTVAG, also you need, for instance, you need the two back solve and a whole bunch of matrix vector product.
Was in theory both imaginary or both.
Right. So, but like if you actually put the both, then that kind of solves an issue. And the other thing is because we don't need that much evaluation, because how it works, each receiver has all the locations, and then that'll evaluate every time. Like, so for instance, how UBC code works, for instance, say what they do, they find all the unique location, one evaluation matrix, then evaluate once, and whatever in time and frequency. So that's kind of like make it more, in a way, it's efficient. I don't think that's very user friendly, and then finding the data, it's not very easy compared to how SimPEG works. But yeah, in a certain level, that like really slow down your speed. For instance, like for good news code, say you have a whole bunch of this evaluation matrix because you have a E field, H field, and you have a two polarization. And if you do that every time, that actually like quite a bit of, yeah, that's a lot of matrix vector product. So
how do you want to interact with that? Because I've been thinking about this a bit as well. Because I also don't necessarily like how the source takes the receivers. I think it makes sense for a lot of surveys, but not all of them. But like when you think about MT, like your receivers are the same for all frequencies. So like, why is every source being assigned
a stack of receivers?
Yeah. So like in some ways, what I would perhaps see is basically like a mapping between sources and receivers. Yeah. Basically, like this receiver is listening to all of these sources, and this source like should hit all these receivers. And then it's also a question too, like how do we want to set up a survey? Because, like, for instance, if you're measuring both EX and EY, right now those are two separate receivers, which I think like makes sense from an indexing point of view, because you want to grab your EX data, your EY data. But they're at the same location and should be using exactly the same interpolation matrix. And right now we regenerate that thing every time.
Mm-hmm. For sake of clarity, but then we're at the expense of efficiency.
Yeah. So like, would you want to then be able to generate a survey by saying, like, receiver, like almost have locations then compared to receivers? Is that I have all of these locations, and then now I'm just going to say that I've got an EX on there, and EY, real or imaginary, EX, EY instead. I know, like, how would you want to interact? How do you want to set up a survey?
Yeah, it's kind of hard. It depends on different survey, right? Yeah. So, for instance, like say,
isn't location always the core, the base?
That's true. That's true. So
the purest thing that defines it.
We definitely just start with the unique locations, I think, but there's a subtlety. For instance, it's EXEY. Yeah. It's not.
Oh, right.
Right, because like they're living in a different place, so we need a different interpolation matrix to do that. So yeah, there's a bit of subtlety on like it's not just the location.
Yeah.
I'm not sure. How I was like sort of using it for instance, DC code. Sometimes I generate one receiver class. One receiver class has all the unique location, and whenever I compute, I just compute it. But like when I'm putting a WD matrix, like this data weighting matrix, I can put the infinite, like at infinity for the location where I don't want to see.
Mm-hmm.
So I think that could be behind the scene. So that's a potential way that we could do it. We can probably use the exactly same structure that we have now, but under the scene, we actually compute the unique locations.
Yeah.
And then
that's a good point though. Like you're saying, let's say for MT, your EX is two poles, right? H is a single point.
Mm-hmm.
But in theory, all like the poles of the E's and location of the H could all be unique, are all unique locations, and you're just doing different operations on those, right? So you're gonna asking the fields on all of those points. Are you gonna keep them or not? That depends on your survey type, but
Something like that.
Because then,
Yeah,
then,
that's-
then it's a single projection, right? You're projecting all your fields on all the poles, and you just get it taken out for your data transformation. Yeah.
Do we want to also have like, because I think in some ways it'd be handy to be able to name data and things like that. So being able to say like the line number and station number and things like that.
Yes.
Is that something that we want,
I thought like
or is that too?
I think I would do in a different place.
Okay.
So I would like work like, say a kind of like a CSV type file format where you have a line like a XYZ types of format, like you have a line ID and all of those stuff. But
Yeah.
I kind of want to separate with the SimPEG survey class. Maybe there could be a kind of easy I/O that can transfer this to here or this to there.
Yep.
But when we're taking the lines and data, I think I kind of want to do it in a different place.
Yep, I think that sounds good.
Yeah, otherwise it's very convoluted and yeah.
No, I completely agree, because I think it does get confusing then, like what we actually require, and like, because we don't need to necessarily be making up our own file format just to work with SimPEG. We need like a vector of numbers that makes sense to SimPEG.
Yeah.
So yeah, completely agree.
Yeah, so that was.
That would be a big major overhaul, though, right? To change this in NTEM and how the survey is created.
Well,
Necessarily.
yeah, I don't think it'll be well, once we got the right structure, I think it's mostly just like parsing things and moving where it leaves.
Yeah, because I think like in a lot of ways, we'll be able to perhaps take a big step forward, not necessarily like a right, but take a big step forward, like sort of for a first pass that should lead to shooting.
Mm-hmm.
Yeah, and then I know you were this weekend with the objective function stuff. There's some weird things with how they're not linked properly.
But now that I understand, I kind of like the way it is because like potentially each of those guys could live on different meshes, right?
Yeah.
So if we try to change all of them from the top, it might not work. It's just because it wasn't documented. But
Yeah. So the issue, in case you guys aren't aware, that Dom ran into, is he was wanting to go and update something on the regularization mesh, like change how we're looking at the gradient operator.
gradient operators, that's it.
And so right now, if you try and access it from like a combo objective function, like once you've the syncing isn't quite right. So the combo objective function has a regularization mesh, but then each of the little pieces that make it up also have a regularization mesh. They should be the same, but they really are only like when you emit. And then they're not actually tied together. So if you go and change something on one of them, you haven't propagated that through.
Should they be the same? Oh, I guess because they're all acting on the same model parameters. Or...
Yeah.
Yeah.
So that's what I'm like inclined to think, is that if you want to like create regularizations on different meshes, then you probably should just be defining like a different regularization and then add them together.
Yes. Okay.
Yeah, so like in a lot of ways, I think that the example that you sent should have operated in as you were expecting. Is that like you should just set the reg mesh on your combo regularization, simple, and then have that you want that's like
Yeah, because if the model parameters are living in different meshes, then they're not they're technically two different objective functions. Yeah.
Yeah, so like I think the thing with the combo regularization, and this is totally up to debate, like the way I sort of first saw it is like we should from the outside be able to treat it the same as like a single regularization. Like it should have sort of all the same pieces all the way through. So that if you call taken off or smallness, like it acts the same. Even though smallness is only like one operation, whereas taken off we're not doing it before.
Mm-hmm. Mm-hmm. Is there any other pieces that are sharing? I said the reg mesh. The reg mesh is the only thing that they're all looking at, right?
Mappings, MREF.
And scales.
Well, the alphas, cell weights. Cell weights, the alphas are different. I can pull it up if you want. Did we lose, Rachel?
Yeah, she just dropped out, yeah. Oops.
Okay, so this is not being fit. That's okay. Oops. All right, so the way it currently yeah, they also share like inactive. There's a lot of things that they share. So if we look at the combo regularization, so we set the alphas, then they share an MREF. They share an MREF in smooth. They share inactive and cell weights, as well as the bright mesh. But the way that they share these things is like I haven't actually properly linked them, and this is something that hopefully Franklin can help us out on. Is that like when we emit this, I make sure that all the things are the same, but they're not necessarily like they're not all pointing to the same object.
Exactly. If you change it during a course, the guy's still going to keep its original. Exactly.
So that's sketchy, or potentially very confusing, which is what I meant by sketchy.
Yeah, because now we need to loop everything when you want to change something. We need to loop through all the children.
Yeah. So that's something that we can run by Franklin and see, because I think he's actually already sort of like implemented that in properties, but I just don't know how. So he might be able to give us like a one-liner that fixes that, and if not, he'll probably be able to point us to what we should be getting.
So when DMT, do you have why exactly? So like what we have right now in the SimPEG framework, how is the code you're working on different? So Guni has published an example, right? The 1DMT.
Oh, I haven't played with the exact same problem. I could do that. Just wrote. So
because you wanted to have a full understanding of what's happening. So
yeah, well, more like we want to make a tutorial.
Okay. So
how Goodney's doing it, it's more like a kind of aligned with his 3D code. So I think it's I don't exactly know how it works, but he compute the primary field using the analytic code and do a secondary formulation to compute if he got some layers or something. That's as far as I know. I haven't really go through, so yeah, it doesn't like resonate with tutorial point. I think not. So yeah, I just end up. And the point that I was thinking, kind of like just show from A to Z, like say how you generate the script of simulation code and sensitivity code and stuff.
Nice.
Now you put that into a SimPEG structure, SimPEG problem class or zero class, survey class, how you parse it out and then generate the SimPEG problem class and actually run the inversion. So that was what I was kind of my scope was that. So we ended up writing it, but I'm not sure what's. We may not put that into actual tutorial, but we could put those as an notebooks, I think. Okay. So people, if someone wants to see, and someone wants to actually implement their code to a SimPEG problem class, that might be helpful, I guess.
I would want to see that for sure.
Yeah, well, works.
Yeah.
Yeah, it can invert for amplitude phase, so it's a little bit difference. So improved a little bit.
Right, do you guys have stuff you want to bring up, or don't you have other things?
No, I still haven't finished it. Look at the PR, working on rotation, so yeah, part time focusing. Research first.
I guess I noticed with the grounded source for the EM problem that Soggy implemented maybe a month or so ago. I think I've been comparing that code with some of the UBC codes, and then also comparing it with the DC code. And I think that as we're doing the integration of the source between the points, I think the current is actually going in the opposite direction we think it's in. Because if I set my A electrode to my B electrode, and I look at it for the DC case, or I look at it for the EM case with a low frequency, like the polarization of some things, there's just a sign flip
Okay.
between those two guys.
Yep.
So I think if I switch which is my A and which is my B in one of the two, then they match pretty nicely.
Okay.
But I can't use the same A and B for the DC code and for the grounded source EM code. I need to flip it in one or the other.
So which one is currently correct in the sense of where, who has A being the positive electrode?
I think the
The
DC,
DC? Okay.
because the DC matches very well with the UBC DC code without having to do any shenanigans.
We don't want to be rich now.
So,
What shenanigans? Okay.
so I think there's just something small
Yeah.
in the way that we're setting up the source and the grounded source EM1, where we're integrating over a path between the two electrodes.
DC matches with the analytics, right? Because it's just a matter of what is plus and what is actually minus.
Yeah.
And the DC matches with analytics, right?
DC matches with the UBC and the analytic.
Yeah.
And I'm able to get, when I was looking at the EM stuff, I was able to get it to match too, but it wasn't quite as straightforward, right? Because we have the different coordinate systems between the UBC code and the SimPEG code, and then we also have they're using the different convention for the e to the minus I omega t versus e to the positive I omega t in the Fourier transform. And so there was a negative complex conjugate that needed to be taken with certain things.
But at low frequency, if we look at the real part, it looks like bombs.
Yeah.
Okay.
I think that's something worth archive.
Yeah.
Probably just at least one datum and what is the signs and stuff that you're supposed to get and what are the conventions that we're using.
Yeah.
Because if you see the problems in UBC code, we don't know actually,
Yeah.
and they have different conventions for different codes.
Yeah.
So historically that has changed it. When L.com they change it. So
Yeah.
when Roman was actually working on it, when Yago was working on it, was this and that.
It's like we're the
Oh yeah.
Yeah.
Yeah, and then you need to rediscover
Yeah.
all those signs, and that's actually not a trivial issue. So you really need serious write down and actually need to run the code.
Yeah.
It takes a while. And if you don't have a ground truth, it's very hard to.
Yeah. Well, to that point, maybe there's a couple of things we could do. Is in the documentation, I think we've documented a couple of these things, but it might not be immediately evident. The other thing that would be really helpful is just showing comparisons to analytics. Basically saying, because when we compute dipole response, we should be matching word count. We're using all the exact same conventions as word count. And so we should be here.
Except that there's a down.
In some examples. Yeah, I guess I was thinking of just the dipole in a whole space.
Yeah.
It's a right-handed coordinate system.
Yes.
So we should, even if you
That's
Flip
true.
it upside down. It's still a right-handed coordinate system.
That is true. Yeah.
So like, basically showing that we should be able to benchmark against something else in literature. Yeah, and I know that you've run a bunch of those examples. So if you had a small one that we could just point to and have in the docs that basically say, like, here's some expectations. That's helpful.
Oh yeah, they probably do the X, Y, Z, that the things you done.
Yeah.
So let's flip it up.
Do you guys want a page in the SimPEG docs that's just like SimPEG conventions?
That's
Yeah.
probably be a good idea.
Okay.
Because I've been asked that question a few times already.
Yeah.
What's the order? We're counting this way, this way, this way.
Yeah.
And
Yeah. UTM.
Yeah.
yeah, UTM, X, Y, Z.
Yeah.
Or we're like, we need to be consistent. Right?
Because you,
All the
yeah.
code should be consistent. so.
Yeah. But also, if we write it down and then,
It's crystal clear then.
we can make issues when we don't match that.
That's true. That's true. And people mentioned the like a mapping.
Yeah.
For when mapping derivative doesn't it actually it provides a matrix. So it doesn't take actually a vector.
Right.
So that's a potentially kind of when your mapping is a functional.
I think there's some weird, it should,
No.
this was something I implemented a while ago.
Yeah.
But I wouldn't be surprised if this doesn't work everywhere.
Because the how you could go ahead, Thibault.
Go for
You
it.
can mention it. Because yeah, like the maze matrix. How if you look at the maze matrix derivative, that's where it fails.
Right.
So I think the structure is actually there, but
Yeah.
the actual code assume it provides a matrix.
Yeah.
So you cannot quite do a certain functional
Yeah.
into your mapping.
Yeah.
So yeah, that's potentially we need to change it. And then that's a simple change, I think. We just
Yeah.
need to take a vector and then.
I think there's actually even a note in base class that says this should take a vector. Yeah.
Yeah, perfect.
Yeah, that's a good call, Thibault.
That's when I was doing this webnet project, I kind of like had to just use, like define my own mapping at some point just to be able to use like Fourier or wavelet transform, which is, you can define it as a matrix, but that is the functional one.
Yeah,
So,
yeah. Very fair. Cool. Okay, I need to head out in just a couple of minutes. So before we wrap up, how do we want to like capture this and make it actionable?
So that's in Google Doc now, or we need to put it into Google Doc?
So I think Thibault's got it on in a Google Doc here.
Nice.
Let's share that. Okay. So we have. Thanks for doing this, Thibault.
Wow. Minutes.
Beautiful.
Well, I think we can just transfer it into issues.
And so what would be helpful there is if, like maybe sort of the main ones that each person brought up, if you don't mind translating that to an issue. And then also if you know where in the code things need to change, like if you can articulate that as well. Yeah, then that helps point things out. Because there are people who are interested in jumping on board. Eric, he was this student in 350. He's very interested in jumping on board and helping out. And some of these types of things, if we can help articulate where these issues are, this is a good way to get to know the code base and also like make a valuable contribution to all of us immediately.
Right.
So yeah.
Right on.
Yeah, and potentially we probably need some actual like a kind of efficiency test for the code.
Mhm.
I've done a couple times.
Yeah.
There's a profiler
Yeah.
that Rowan wrote before. It's not like really handy, like in terms of visualizing, but like it's actually pretty nice. Just rather than doing typing things, but
Yeah.
like it actually like profile things and check how much time that you're spending for a certain part.
Yeah.
Yeah, I think especially EM codes, I
Yeah.
think we really need to do it
Yeah.
for a relatively big size problem, and also DC codes where like it is nonlinear code. I think there could be some part where you got pretty big memory, which you're not supposed to, or like a certain part is not very inefficient.
Yeah.
Because my feeling, like we should supposed to get similar efficiency with the UBC code for a 3D code, like at least a tensor code, if you're using very similar solver.
Yeah.
Yeah, so I think we can do it, but like there's some parts where we're not just don't know.
Yeah. Well, that there's a couple ways we could do that. If you want to put some stuff in the docs, like just with an example that you want to see, you can do that. The other thing is if we actually have like a folder full of sort of efficiency tests where we want to spin up some stuff that is a little bigger, we can change Travis to basically like only test that on pull requests or things like that to make sure that before we merge anything big, we haven't at least like destroyed our current expectations of efficiency. So, yeah.
Yeah, I think that's probably probably a right time to do it because we're pretty evolved, and I think it's pretty stable now. Codes.
Yeah, so at least changes we make, we shouldn't be doing any worse.
Yeah, exactly. Because so I've done like I don't know years ago, and I thought I was happy with that.
Yeah.
But like you change it,
Right.
but like you expect it should be pretty similar.
Yeah.
But no, it's different.
Yeah.
Surprise, surprise.
Yeah, it's surprising. So.
Cool. Okay. Yeah. So we will type out some issues and start hitting on some of these things.
Sounds good.
Cool. And if there's any that you personally want to tackle, just tag yourself as the YouTube champion, and then we know that somebody's got it on their radar. Otherwise, they kind of float around. So.
Sounds good.
Perfect.
Thanks, guys.